Hello everyone and welcome to another day in the adventure of a triangle. Today we're going to be talking a little bit about trigonometry once again, finding the sides of a right triangle given one of these angles when it's not like super obvious given this angle what the other sides are going to be. So there's not a lot of information here. We technically have two angles in one side, but it looks pretty bare bones right now. And we're going to be using trigonometry to find both of these other sides and this angle. The angle's not going to be too terrible, but two sides we're going to have to use trig for. I'm going to make a separate video for how to find the angles because sometimes you can be given sides but not the angles. And you can also use sine, cosine, and tangent to find those. So that's the objective. So first of all, the important thing to note, once again, we've called it SOHCAHTOA, where sine of an angle equals opposite over hypotenuse. Cosine of an angle, theta is the symbol by the way, is adjacent over hypotenuse. And finally, the tangent of an angle is opposite over adjacent. For this lesson, it's very important that you draw the theta. Don't just write sine equals, cosine equals, tangent equals. I sometimes shorthand it myself, to be honest, but make sure you're not doing it. It is very important that you are writing that because now you are actually going to be given an angle. This is going to be one of those things where this is three variables: the angle, the opposite, and the hypotenuse. These are three different numbers. And in these problems, you are going to be given two of the numbers and you have to solve for the third. Or you're going to be given two of the numbers and you have to solve for the third. Or you're going to be given two of the numbers and you have to solve for the third. But it is important to note that these three things are going to be numbers. If you're given an angle, you're going to plug it in here. If you're given the opposite, you're going to plug it in up here. If you're given the hypotenuse, then you're going to plug it in there. Or maybe you don't have the opposite and hypotenuse. Maybe you have the adjacent, in which case you don't use sine, you use cosine. Or maybe you are doing this one over here. So let's just go ahead and start. Let's pretend for a second this problem specifically said to find this side. This doesn't. We're going to find everything, but in problems that you're given, sometimes you only need to find one side. If that's the case, you want to label all three sides: opposite, hypotenuse, adjacent. So here, this one is the hypotenuse. If you go across, this will be the opposite, or another way to think about it is the adjacent is next to the angle and not the hypotenuse. So this is the adjacent, and this is the opposite. And what you look for is which two sides are labeled. Now here, the hypotenuse is obviously labeled as 17 inches. A is absolutely nothing, and the opposite is x. So we are actually counting x as something we have. We have the side opposite as our variable, and we have the hypotenuse. So you'd say, well, we have the opposite and they have the hypotenuse. Which of these three things has the opposite and the hypotenuse? So you look, this has the opposite but not the hypotenuse. This has hypotenuse but not the opposite. And here we are in the sweet spot. Sine uses opposite over hypotenuse. So I'll write down sine of theta equals opposite over hypotenuse. And you plug in what you know. So sine of theta, do we know theta? Theta is an angle. Yes, we do know the angle. It is 54 degrees. Then, do we know the opposite? Opposite, we labeled as x, so we'll put an x. And finally, the hypotenuse was 17 inches. I'll just write 17. And then you have to solve for x. In this one, what you do to solve for x is you multiply both sides by 17. That way, these will cancel. And you end up with 17 times the sine of 54 is equal to x. And we're just going to plug that into a calculator to find it out. So 17 sine 54. So 17 times the sine of 54 degrees. Desmos is automatically in degree mode, so you don't have to worry about that. We're going to round to two decimal places, so this will be 13.75. 13.75. 13.75 and it's inches. So I'll go over here, 13.75 inches. Boom. Awesome. You now have two options to find this. You can either use trigonometry again, or you can use the Pythagorean theorem. This is still a right triangle. Later on, we sometimes don't do right triangles, but since this is a right triangle, you can do a squared plus b squared equals c squared. It's somewhat accurate to do that. You're going to get a lot closer because, you know, there's a bunch of decimals, as you saw on this thing. We're just rounding it. Rounding gets worse and worse the more you use rounded numbers, so it's safer to use trig. So I'm going to do it again. So if I want to do this one to solve for this angle, or side, now I'm using the adjacent and hypotenuse. So which of these uses the adjacent and hypotenuse? Cosine. So I would say the cosine of the angle is equal to the adjacent over a hypotenuse. But we know that the angle is 54. I forgot to write 54. And once again, we would multiply both sides by 17. Get rid of that. And then we'll type this into my Desmos. 17 cosine. I'll just go 1, 2, 3, 1, 2, 3. And there you go, a 9.9923. So 9.99. So this is 9.99 inches. Oof, almost 10, not quite. And that is all three sides. For the last angle, you might be able to guess. If you have two angles, how do you find the third angle? That's just that the angles have to add up to 180. So if you take 180, subtract the 90, subtract the 54, you'll get that. Or some people say, well, these two angles have to add up to 90. So do 90 minus 54. So 90 minus 54 is 36. So we'll put down 36 degrees and we're done. Boom. Okay. So now we have all three sides and we have all three angles. Boom. If you want to give this one a try, you can just pause it, give it a shot. Otherwise, I'm just going to do it. Here is our angle. This is the hypotenuse. This is the adjacent, and this is the opposite. We are definitely given the opposite. We are finding the adjacent or hypotenuse. But we're definitely given the opposite. So we have to use either sine or tangent. I'm just going to use tangent because I haven't yet, and I like doing things differently. So I'm going to set up the tangent of the angle is equal to opposite over adjacent. Do we have the angle? Yes, it's 38. So tangent of 38 degrees equals the opposite side, which is 5, over the adjacent, which I don't know. So this one is different because 5 is on the top, not the bottom. In the previous one, it was a 17, and we just multiplied by 17. Here, the long way is you would multiply both sides by a, because if you multiplied by a, they'd cross out, and then you'd have an a in front. And then you'd have to divide by the tangent of 38 on both sides. But shortcut version is you can flippy-floppy these things, or switch those two things, to make it a is equal to 5 over tangent of 38 degrees. This thing is shaking a lot. But just go ahead, plug that in here. I'll just backspace it. And I already forgot what I wrote. Ooh. Let's see. 5 tangent over 38. Okay. So 5 over tangent 38. And it says 6.3997. So that's going to be 6.4. So this will be 6.4 feet. There we go. Now to find the last side, I could use Pythagorean theorem. Let's just do it, because why not? 5 squared. Oops. Okay. 5 squared plus 6.4 squared is this thing, but then we have to square root it. So, oh wait, square root is over here, I think. Yep, boom. Square root of 65.96. And it says 8.12, etc. So 8.12. Like that. And you know, if we use trig, we'd probably get the same thing. If I used opposite over hypotenuse is sine. So I would say the sine of 38 equals the opposite side of 5, or the hypotenuse, which I don't know. So I would do 5 over sine 38. 5 over sine 38. And look, it's pretty much the same number. Not exactly the same number, because once again we rounded, but 8.12, you know, 2 decimal places, it's the same. So good times. Lastly, I guess 90 minus 38. 90 minus 38. Oh my goodness, why is this not working? 90 minus 38. It's 52. Woot. Degrees. Okay, and that's all 3 sides and all 3 angles. Sometimes you need all of them, sometimes you don't, but that's how you go through it. Okay, that is how you find the sides using trigonometry. Later on, we'll do how to find the angles using trigonometry. Have a good one.